Hello, I'm Mark. One more feature for the AOScope program. Well, I keep adding features. So the last one I added is was a request for some simple logic output, the ability to set a line high and then set a line low, or just to give it a single pulse. To get multiple pulses, we've already got the clocks. We can set them up for once a second, give a 100 microsecond pulse. So that's all working just fine. But if you just want one pulse, that's kind of a pain. So we added a couple of features. Let me go back to the manual here, and if I spin it around, there's one here. It says the logic output is on the same pin as clock C. So, you know, this will take over clock C. But if I connect the clock C output, which is D12, back to the A0 input, so we can demonstrate this. And then we've got a couple of L commands here. They're not too difficult to remember here, so we'll just let me go that. So I've got the D12 line connected back into the A0, and here is our AOScope program. Let me just reset it to make sure that everything is I just pushed the reset button. Okay, so we're back to a normal. And then, so we've got this. And let me just hit a blank return just to, you know, that's where it comes up when you have those two shorted, so we get the nice pulse out. Okay, so now if I say I want the logic high or logic low, that's kind of hard to see. So let me put this thing back into slow scroll mode. So let's make it. Let's divide the scroll speed down to every 100 times a second. So SC100. That's the 10,000 per second divided by 100 equals 100 times per second. Okay. So I did SC100, and up here you can see that we're going to sample once every 10 milliseconds at this point. And then the other thing I want to type is SS for the smooth scroll mode. Now, we've got the clock is still giving us that 1 second tick that's only 90 counts or 9 milliseconds in length. So that gives us a spike that we're seeing right now. So if I want to give a logic output instead, well, let's see here. Let me bring this up just a little. Okay, so if I want a logic output instead, I can come in here and just say I want to be logic high and hit return. And you can see the output signal just goes high. Now, you can see that the A1 line is floating along. I'm going to go ahead and short that to ground off of A1. So, and you can do it. Well, okay, the line is floating. As I'm touching the wire, you can see it move around a little bit. And I'll just take it to ground so it gets out of our way so we don't see that. Okay, so now it's I said logic high, and it was logic high. If I say L logic LL or logic low and hit return, you can see the signal just goes to low and stays there. Very simple. If I say LP, saying I want a single pulse, I can give it how many ticks at that 100 microsecond per tick type things. So if I want to go for a tenth of a second pulse, that would be 1,000. So LP 1,000 would be one pulse that is a tenth of a second. Okay, you could see that pulse is not very wide. Let me make it even longer. Let me make it a full second. LP 10,000. So logic pulse LP 10,000. There's a pulse 1 second wide. Okay, so that's not so bad. Okay, now I hate to keep typing these things in every time because sometimes, you know, when you're working on electronics and you're feeding this into some other logic gate, you'll want to give it a pulse and look at something, give it a pulse. So if you ever just type an L and hit return, it'll give you that same pulse again. So it's really easy just to type an L and hit, and it'll give you another pulse whenever you want one. So that's a full second. So let me go LP 1,000. That's the tenth of a second one. But again, I can just take and hit an L whenever L in return, so I can generate pulses slowly. So you've got some simple logic output levels. Now, don't forget we've also got the digital outputs or digital lines that we can watch, which are at the top. Those 4 lines. We didn't really talk about those much in the other videos, but if you've already got an analog signal and you're just looking for a digital one, we can go back up at the top, and here's our sources that tells you where everything's at. You know, the A0 is on analog port 0, analog port 1 is A1, digital port 2 is on D2. So let me just take this digital pulse and let me move. Let's see here. Let me move instead of A0, let me move this to D2. So I'm going to take the D12, which is my output, and I'm going to just wire it straight to D2. And that looks like it's right about there. Okay, let me go back to my scope program. So now, when I say an L and hit return, I get that pulse. And you can see it's clear up here on the top, going by. So if I need to watch several things at once, you know, I can connect those logic lines up to anything and still have the 2 analog ports to actually watch things that are changing in the analog side. Okay, I just thought I'd give you a quick on that one.